Let's begin binomial probability distribution. So, binomial probability distribution is for only those experiments whose outputs are only 2 in numbers. So, only those experiments having only 2 outcomes, that is true or false, success or failure, 0 or 1, that is binary, head or tail, it has only 2 outcomes, dead or alive. So the experiments having success or failure, 0, 1, dead or alive, only 2 outcomes, it deals with probability, binomial probability. So let us explain what is binomial probability. So suppose we are appearing for some exam, and this P is the probability of getting success, Q is the probability of getting failure, which is counted by 1 minus P. If I know this value P, anyhow I know what is the probability of passing the exam. I can calculate that, or it is given in some questions. N is the total number of times I am appearing for some examinations. Say 20 times I'm appearing for some exam. So, and what is R? R is the number of times I need success. I need to clear that exam. Suppose out of 20, I want to clear 12 exams. So R is 12, N is 20. The question is, what is the probability that I will get success R times out of N exams? Such questions which has only 2 outcomes, either I'm going to pass or fail, we find binomial probabilities in such type of questions which has only 2 outcomes. So binomial probability is denoted by BNPR. What is N? N is total number of trials, means exams. P, since I'm interested in success, I'm writing P. If I want to find the probability of failure, I will write Q here. And R, how many times I want to clear. So the formula is NCR P raised to R into Q raised to N minus R. So this is the formula for binomial probability. So let's take one more explanation for binomial probability distribution. If suppose a shooter knows that he can hit or kill 3 out of 5 targets. He can kill 3 out of 5 targets. What is the probability that he will kill 7 targets out of 11? So I have to realize that I am dealing with a binomial probability, because that shooter is going to hit or going to miss the target. So there is only 2 options for that shooter. So probability of killing is 3 by 5, because he knows that he hits 3 out of 5. So the probability of killing is 3 by 5. So this is the P. This is success. This is success for that shooter. Probability of missing is 2 by 5. You have to calculate this by 1 minus P. 1 minus P is 1 minus 3 by 5. So 2 by 5. So total number of targets given to that shooter is 11, which is N, and he wants to kill 7. So the question is, what is the probability that he will kill or hit 7 targets out of 11? So you have to realize it is a binomial thing. So the probability B and P are, N is 11, P is 3 by 5, R is 7. Formula is this. Put everything into the formula. So B11, 3 by 5, 7. You can denote this binomial probability by P of 7 also. P of 7 is the probability of killing 7 target out of 11. or simply sometimes B by B7. So this is the 11C7. So I'm just putting the values of N, R, P and Q in this. So calculate this. 11C7 is 330. 3 by 5 raised to 7 is this. Just multiply this, you get this much. So the probability that the shooter is going to kill 7 out of 11 is very less, closer to 0. 0.23, which is very less. So this is the helping explanations for binomial probability distribution. Now let's take example. So what you have to remember is this formula. This is the important formula for binomial probability. Let's take few examples. This is the simplest one. An unbiased coin is thrown 10 times. Find the probability of getting exactly 6 heads. So we have to find the probability of getting exactly 6 heads. So this is the binomial experiment, which has only 2 outcomes, head or tail. So let's define our success in this experiment is getting head. So P is the probability of getting head. So if I do this experiment only once, means if I am tossing a coin one time to decide what is the value of P and Q, so it is half. So for one toss, probability of getting head is 50-50, and for tail is it's 1 by half. For head it is also 1 by half. So P and Q in this case both are same. Now I am tossing that coin 10 times and I want to know what is the probability that I am going to get 6 heads. What is the probability of this event? So B and P are, N is 10 times I am tossing that coin, P is the success probability, which is half, and 6 is the number of times, that is 6 times I want head. So 10 C6, so you can calculate this thing. So I am elaborating this question. What is the probability of getting at least 6 heads? So in this case, in previous example, we were finding exactly 6 heads, the probability of getting exactly 6 heads. In this case, we have at least. So at least means it's okay if I get 6 head or 7 head or 8 head, not less than 6. So I know that what is P of 0? P of 0 is the probability of getting no heads. P of 1, probability of getting 1 head. 6 heads. 7 heads. And like this I can go up to P of 10. I am interested in this. What is the probability of P6 plus P7 plus P8, P9 and P10? Since it was at least, so my interest is in this sum. So you can keep this on one side and move this on that side. So this is 1 minus, or you can calculate P6 separate individually, P7, P8, P9 individually. So what I have done here, it's this. You can calculate this by using calculators. So let's take the other question. So the question is, on an average, a box containing 10 articles is likely to have 2 defectives. So there's a box containing 10 articles and we know that out of 10, 2 are likely to be defective. If we consider a consignment of 100 boxes, how many of them are expected? So how many boxes out of 100 boxes are expected to have 3 or less defective items? So let's look at the solution. P. What is our success in this? Success in this is to identify how many boxes are having defective things. So probability of box containing defective articles is my success in this. P. So my P is this. So out of 100, on an average box containing, so one box contains 2 defective out of 10. So 2 by 5, 2 by 10, so it is 1 by 5. So the probability of getting defective articles is 1 by 5. Q, it is the probability of box containing non-defective. So just subtract 1 minus P. 1 and P, so it comes 4 by 5. Since the items can be defective or non-defective, which is only 2 outcomes, so it is a binomial probability. So we have to find how many boxes are having 3 or less. So probability of 3 or less defective, it can be denoted by this notation also. P less equal 3 or PR less equal 3 is nothing but P0 means a box containing no defective articles, a box containing 1 defective article plus a box containing 2 defective article plus P3. So these are the probabilities I want to calculate. So this contributes to 3 or less than 3 defective articles in a box. So it's a binomial distribution. So I'm taking this new notation PR. So BNPR, it can be denoted by PR, simply PR also. The formula remains same, NCR P raised to R Q raised to N minus R. So let's find this P0.